Hi everybody, we have one last lab to get through for Physics 2, so I'm Colin and let's get started. So we have a magnet falling down a tube, and our purpose of this is to observe how Faraday's law, Lenz's law interact with gravity and using Newton's second law to analyze it. So we have Faraday's law, which is a changing magnetic field creates a current. Then we have Lenz's law that says based on which direction or the increasing or decreasing field, then we're going to have what direction the current flows in. Then based on that current, it's going to make another magnetic field that opposes the first one, or that opposes it. Then we have Newton's second law, which is pretty much just saying that forces add together, which is not the entire story, but that's what we're using it for. And we have gravity, saying that the force of gravity is just mass times the constant g downwards. So we have our preview and initial conditions. This is just this. This is what our tube looks like. I can't imagine these numbers. Our system is a falling magnet. Our surrounding is the aluminum tube and the Earth. That's our preview. This is a video of us dropping it. Beautiful. So our physical test averaged around 1.13 seconds of falling through the tube, and our coding came to be 1.279 seconds of doing tube stuff. So for the physical part, this is where I'm going to explain how this actually works. The falling magnet creates a changing magnetic field. Because, it's falling, it's hitting at different points at different times. Changing magnetic field produces current, which is this current is going to make a magnetic field that counteracts the first magnetic field. This new magnetic field produced by the tube is going to be calculated by V of this tube, the magnet, times its own magnet, the tube's magnetic field. That means there are two forces acting on this falling magnet. There is going to be gravity, which is from the Earth pulling it down. Then we have a magnetic, which is going to be upwards of this new tube magnetic field of V cross B. And so since the magnetic force is based on velocity, that means it has to be moving a little bit for it to be working correctly. And so it'll just move slowly because gravity is a little bit stronger than the force of the magnetic tube. And then how do we code that? So we're going to have how we calculate dipole magnetic fields, and we're going to have our new equation, which is calculating the deflux for Faraday's law. So we got all this jazz. Then we have F of this is a forces section. We have the F of the gravity, which is going to be just mass times g. And then we are going to calculate this guy, which is the change in flux, which is this guy. Then from that change in flux, we can then calculate the gravity from the magnetic field from this, or the current from this, turn that into magnetic, and then make a new magnetic force. Then we're going to have the force of the magnet on the force of the magnetic field from the tube on the magnet. Blah. So the result of our coding, this guy fell through. It was actually pretty cool to look at, and we found that our magnet fell at 1.279 seconds. So, sources of error and comparison. I'm human. I was looking at these timestamps. I did the best I could to figure out when it entered and when it exited, but I can only be so good at that. Incorrect. We had some trouble massing it, so the magnet might have been the wrong mass, and we had a crumple aluminum, which was acting a little funny. So we were pretty close, actually, with our coding compared to our physical test, which is good to see. What if questions? What if the resistivity of the conductor were as close to zero as we possibly could? So pretty much our currents would become way stronger, and because our current become way stronger, that means the magnet would, the force of the tube on the magnet would be extremely strong, and since it's calculated by, it could almost go to being stopped. But it's not, because V cross B would never go to zero. What if there were holes cut into the tube? How would this affect the ring? The currents would become much weaker because we would have incomplete rings that aren't able to hold a good of a current, and the magnet would fall faster, and it might even fall out of one of the holes because it started acting like a line charge instead of like a ring. And thank you, and congrats on making it through Physics 2. Yippee!